So let's understand variables and identifiers. Now, variables. What is a variables? So we already have seen in the keywords, we already have taken a equals to. So if I write a equals to 10, this is what? This a is a variable. So what is the syntax for a variable? Variable equals to value. Variable equals to value. This is what the syntax is. And as an example, this is what the variable and this is what the value is. Variable and the value. Now, whenever I am writing this a equals to 10, what we are exactly doing? Are we storing 10 inside a? So, if you go for the memory allocation, which is very, very important, like what is happening whenever interpreter seeing this a equals to 10, what exactly is happening? So, when interpreter will see a equals to 10, what will happen? Memory means the RAM. This memory will segregate in two parts. One is variable space and other part is value space. Now this 10, whenever you are giving this 10 is actually randomly stored somewhere. If you see, if I give 10 also or 20 also, it will take by the interpreter. Now, if I tell you, let's go and fetch that 20. Can you fetch that? If I go to check whether it is already stored or not, I will be using id. Id, it is an inbuilt function to check to whether it is stored or not. So it will give you, like id is giving you the exact location of the value you are storing. So if I give id of 20, it is showing some integer address. So this is what the memory address it is showing. Now if I want to access this 20, I have no backup. So, what is happening exactly? Whenever you are giving 10 or 20, let's suppose go with 10. If I give 10 randomly, it is getting randomly stored somewhere in the memory. Inside a memory block, a single memory block, it will get stored. Now, it will be having some address. So, generally, this address is in integer address. For our assumption, let's take some hexadecimal address. Let's suppose I am taking 0x32. So this is my address. Now this address, what this variable is doing, variable will be stored in variable space and this variable will store this address so that you can access this 10 later. That is why variable a, it's not storing directly the value, it is storing the address of that specific value. So what is a variable then? So as a definition, what we can do, we can write that variable is a container. Variable is a container. This container will store the value? No. For this is a container for storing the address of the value. Address of the value. Why to store an address? Because if you want to access that value later on, what you will be doing, you need to store that address, you need to store the location to reach up to this value, right? So you need the location of the value. That is why variable it is there to store that location. So what variable is doing? Variable is storing the location of the value. Now if I take multiple variable with value, how it is taking. Now before that, let me tell you that in python you don't have to mention the type of any variable. Simply if you take a equals to 10, automatically it will take 10 as an integer, it will be seeing in data type. Whereas in different programming language, if you go for c or java, you will be seeing that whenever you are taking 10, you need to write like this: int a equals to 10. So here, if you mention, like here you need to mention the data type, and this variable will take only 10. If you're changing it to 10.5, it is not possible. This variable only reserved for integer values only. So that is why in C or Java, whenever you are taking these variables, those are actually fixed, those are actually static. Whereas in Python, whenever you are taking this a equals to 10, this is actually, you don't have to mention the type of it. Automatically, it will detect which data type you are giving. So this is how it is actually called also dynamically typed. Dynamically typed means automatically it can detect. Like if you change this 10 into 10.5, on the same way it will take. Like there is no such limitation that this variable only take integer value, it can take float value also. What is integer, what is float, I will be coming. Now let's talk about multiple variable creation. Multiple variable creation. Now let's suppose I have four variables: a10, b20, c30, d40. Now if I want to store this four values address in four variables, we have to write these four lines. But as because Python is very easy language, each and every lines, like here we don't have to waste these four lines. Rather, we can write this entire four line in one. How? A comma B comma C comma D equals to 10, 20, 30, 40. This is how we can do what? Multiple variable creation. So if I run this, A comma B comma C comma D equal to 10, 20, 30, 40. So if I run this, let's go for A, it is accessing 10. Let's go for B, accessing 20, C 30, and D 40. So what it is actually happening here? If you go for memory allocation, again I am showing memory allocation. So this memory on the same way, it will going to divide in two halves. One is variable space and other one is value space. Now if I ask you one question, like which one will be getting stored first, your value or the variable? So variable which it is storing, it is storing the location of the value. So value should be get stored first, so that is why here the value will be get stored first. Now next question is, will this value will be getting stored, like 10 will be stored, right? Some hexadecimal address it is getting generated 0x51, let's suppose. After that it will be getting stored inside a? Obviously no. First, for this multiple variable creation, all these values will be getting stored first, means 10, after then 20, some address 0x32, then 30, any random address in a random block 0x99, and for 40, some random address 0x10. And after that all this variable will take the location of those value. Like A will take the location of 0x51, means A will be pointing to this location. For B, B will take this value 0x32, now B will be pointing to this location. C will take this 0x99 location and pointing to 30. And on the same way for D will get the location of 40, which is 0x10, and it is pointing to this location. So this is how it is actually happening. That is how you, if you give A, it is actually what it is, interpreter what it is doing. Whenever you are giving A, interpreter will search for A, and then it will see that it is storing some location which is 0x51. Now interpreter will check for where is 0x51, here it is, and the value is 10. So this is how it is giving 10. Okay, now let's suppose I am changing this A, I'm changing this A into 20. A equals to 20 I'm giving. So now what it is happening, if I give after this I am changing the A equals to 20. So what will be happening? Just check, just check id of a. Like now a is 20 and already we have b which is 20. Now id of a, this is the location of a. Now if I check id of b, what is the location of b? Same location. Means now it is not pointing to 10. A is not pointing to 10. Now it is pointing to 20. Like once you are writing a equals to 20, this will be cancelled and now a is pointing to this location. Means the previous address will be replaced by 0x32. And this phenomena is called overriding. Like it will be overridden by the new location. So now A is pointing to this location only. Like A and B both are pointing to the same location. That is why the ID of A and ID of B are same. Now, if you check ID of 10, see, it is completely different. Now, is there any variable pointing to 10? So if you see, there is no such variable which is pointing to this 10. Now, from here, there is one concept is coming which is reference count. Reference count. Now, what is this reference count is? Reference count is giving you the count that how many variables are pointing to a particular value. Like if you see the reference count of 10, what is the reference count of 10? Means how many variables are pointing to this 10? There is no such variables. So the reference count here of 10 is 0. Now, on the same way, if you go for the reference count of 20, the reference count of 20 is 2, as because A and B both are pointing to the same location 20. So, the reference count is 20. Now, on the same way, the reference count of 30 is 1, and on the same way, the reference count of 40 is 1 because one variable are pointing to this location. So this is what called reference count. So what do you mean by reference count? This is the number of variables pointing or pointing to a value. That count is called reference count. Now here, as because this 10, it's not being used by any variable. So later if you're going to access this 10, there is no such backup or there is no location or the address, it's not saved somewhere. So how to access 10? So there is no such way to access 10, as because you are not storing that 10, not storing that location of 10 anywhere in any variable. So if the reference count is 0, means if any value is not being pointed by any variable, variable those values will be automatically get garbage collected. Like in other programming language, you don't have to free up the memory. If there is one value which is not being used by any variable, those values automatically getting garbage collected. If the reference count is 0, the garbage collection will be happening, but when the garbage will be collected, that is depending on the time. Like if you close this, ideally obviously it will be garbage collected. And even um like after some hours later, automatically this is automatic. Okay, so automatically this 10, as because the reference count of 10 is 0, it will be automatically garbage collected. Now let's suppose I'm giving one more scenario. Let's suppose we are doing a multiple variable creation ABC and it is having value like 10 and 20. Or otherwise, this is a case 1, and case 2 is I'm giving ABC, three variable with 10, 20, 30, 40, four values. Now, for both cases, as you can see, let's check, will it be possible if I give A, B, C, A, comma, B, comma, C equals to, I'm giving what? 10, then 20, then that's it. So here it is showing what? Value error. Why? Because of here A is pointing to 10, B is pointing to 20. But what about C? There is no such value whose address will be stored inside C. So here you will be seeing insufficient insufficient value problem. Whereas in case 2, just check case 2, is it possible if I take more than variable, if we take more values like abc equals to 10, then 20, then 30, then 40. If I go with this, again same value error. What it is showing? Too many values to unpack. So the problem here also, insufficient variables, because a is pointing to 10, b is pointing to 20, c is pointing to 30, but there is no such variables present who will store the address of 40. So here there is a deficiency on variables, so it is for insufficient variable. Fine. So for both case, the output will be what? It will throw value error. So from this cases, what you have understood, that always your for multiple variable creation, always your number of variables should be equal with your number of values. Always it is, you have to maintain this. Now let's go with some different cases. Now I'm giving one case. Let's take multiple variables with same values. Multiple variables with same values means what? Let's take a comma b comma c, and I'm taking 10, then 20, again 10. So as you can see, multiple variables means a and c are pointing to 10, like both are actually having 10. So what will be the memory allocation? Let's take the memory will be divided into two halves, right? Variable space and value space. Which one will be getting stored first, your variable or the value? Obviously the value will be getting stored first. So how the value will be getting stored first? All the values first will be getting stored. So 10, so randomly somewhere in the memory, randomly 10 will be getting stored first. Some random address 0x12 will be generated. Again next is 20, 20 will be getting stored, then 0x33, this is a random address, let's suppose it is generated, hexadecimal I am taking. After that 10 again. Now interpreter take or store this 10 again. Interpreter will check whether this 10 present or not. Actually when it is going to store some value, it will check whether this value present or not. So when 20 is getting stored, is actually checking 20 present or not. If 20 not present, then only it will assign, otherwise it will not. As because 10 already present, it will not store that 10 again. Okay. After then all the variables will come into the picture. Variable a is pointing to what? 10. So what is the location of 10? 0x12. So 0x12, 0x12, so a is pointing to this location. On the same way b is pointing to 20, so what will be the address? B will store 0x33. Now 0x33 will be stored by 20, sorry, by b. And after then c is pointing to 10 also. So what is the address of 10? 0x12, which will be stored inside c. So c is pointing to this location. So this is how it works. So means what? You, if you have same values, the same value will not stored inside the value space again and again. Once it is getting stored, it will not going to store it again. Fine. So if you go for here, reference count of 10 will be 2 and reference count of 20 will be 1. Correct. So this is how we can execute. So if you go for this also, a comma b comma c equals to 10 comma 20 comma 10. So if you go for the id of a, see the id of a and see the id of c, is it same? See, it is same because both are pointing to the same location. And go for the id of b, it should be different, right? So see that this is what the difference is. It is completely different. Okay. Now, last case for multiple variable creation. So let's go for case B, where we are taking same variables with multiple values. Let's take same variable with multiple values. So same variable, I'm giving the heading same variables with multiple values. Multiple values. So let's take A. A is a variable. So I'm taking same variable with multiple values 10, 20, 30. So what will be happening? First understand by the memory allocation. So what will be the memory allocation here? The memory will be divided into two space, variable space, variable space and value space. Now all the values will be getting stored first. So 10 it is not present inside the memory, so it will take a block randomly and the random address will be generated 0x19. Now again 20 is it present? Interpreter will check, is it present in the value space? No, then 20 will be getting stored. So the address, let's suppose 0x75, it is generated. After the 30, interpreter will check, 30, is it present here? No. Then 30 will be getting stored. So 0x171. Okay. After that, A. Now A is a variable. First of all, A is pointing to what? 10. So what is the location of 10? 0x19. 0x19 will be getting stored. 0x19. After this, again, A is pointing to 20. What is the location of 20? 0x75. Now, this 0x75 will override this previous location and now 0x75 will get stored inside A. After this, interpreter will check that A is again pointing to 30 also. Now, what is the address of 30? 0x71. Now, again, this previous location will override this previous location will be overridden by the new location 0x71. So finally, A is pointing to this location only. Means if you have same variables with multiple values, always it will take this line is equivalent to A equals to 30. Means always your new value will override the previous locations. Fine. So this is how it works. Always new addresses will override the previous address. So this is how it works. Now, let's understand the identifier rules. Means like we have seen how the value is actually working. Now, let's talk about how these variable names are being created. Now, let's